Welcome to JEE Advanced tutorial videos. My name is Robin and today we are going to discuss one of the most important topics of JEE Advanced Mathematics, which is integration. And in that we will discuss integration by parts. So before moving to integration by parts method, guys, I'd like to tell you why this method is important. So guys, this method is important if we want to solve any complex problems which includes product of functions and that function is complex, then this integration by parts can help us in solving those functions. So guys, as you can see, integration by parts, and this is one formula written. So what is this formula and why when we'll use and where will we use, we'll see that. So guys, integration by parts is mainly used for product of functions. So guys, as we all know, JEE is all about solving questions within short span of time. So if you are given any complex problem and you want to solve within few minutes and by applying some logic, then integration by parts is the best method to solve that integrated equations. So what we'll do in that, we'll use one formula which is written here. It's like integration of first function into second function equals to first function into integration of second function minus integration of differentiation of first function into integration of second. So guys, we'll see later how this equation has been derived. We'll derive this equation, and as I told you, this integration by parts is mainly used for product of functions. So now what is product of functions? So if we are given any functions like integration of sin x cos x, these two are functions and this is product functions, then you can easily solve these functions like divide by 2 and multiply by 2, then it will become integration of sin 2x upon 2 and later so on you can integrate. But there are some times when you'll get some function, product of functions, but you can't solve that within short span of time. So that time you have to apply this integration by parts formula. So let's see that kind of example. So suppose this we have been given function to solve x sin x. So guys, there are some conditions where we use this integration by parts and there are some priorities which we use while solving these equations. So as you can see here, it's written ILET. So basically what we'll do is, ILET is a procedure. I mean, it's like I for inverse, L for logarithmic, A for arithmetic, T for trigonometric, and E for exponential. So guys, these are the priorities that we set. So as you can see, this is a x variable and this is a trigonometric function. So applying to the logic, we will take x as our first function because arithmetic is x and sin x is trigonometric. I mean, you can relate with it, right? Like x is arithmetic and sin x is trigonometric. So you can relate is, we'll keep priority like A is on the top priority with respect to trigonometric. So we will take x as first function and sin x as second function. X is first function because A is arithmetic, that is x, sin x relates to trigonometric, that is second. So priority will be 1, 2, 3, 4, 5. So 3 and 4. So we took x as first function, sin x as second function. So now when we apply this formula, directly you can see we will get results within short span of time. So let's apply the formula. Formula says fx gx equals to fx integration of gx minus integration f dash x integration gx. Let's apply this formula here. So guys, this is our first function, so it will be fx into integration of second function, that means sin x minus integration differentiation of first function, that is differentiation of x, that will be 1 into integration of second function. So guys, it came like minus which will become minus x cos x plus sin x. So guys, now you can see clearly like how we can solve this complex equations within short span of time and just by applying this formula. So guys, now we'll see how this formula has been derived. So let's start with the derivative part of this formula. So to derive this formula, what we will do, we will take two parameters uv with respect to and differentiate with respect to x. So it's like differentiate v into du by dx plus u dv by dx. Okay, so now what we'll do, duv by dx minus v du by dx equals to u dv by dx. So guys, what we'll do now, we will take u as function x and v dv by dx as gx, which will become dv equals to gx dx. Integrating both sides, we get gx dx. So guys, we'll put these equations in these equations and let's see what happens. After we integrate both the sides, we have taken u as fx and dv by dx as gx. So dv by dx equals to gx, so integration of dv equals to gx dx. So in direct it will become v equals to integration of gx dx. Now let's put this in this equation. So let's see what will happen. So it will come integration of u equals to fx and dv by dx equals to gx. Here we have seen v equals to gx dx equals to first function which is fx integration of gx minus, solving this we will get integration of f dash x into integration of gx dx. So guys, this formula, this is how we have derivated. So guys, as you can see, this integration by parts is very easy to learn, but just you have to think of like where you can use that. Like when you get some product of functions, then you can apply this, but you have to take care of this Euler rule. It's like whenever there is a function, inverse, logarithmic, arithmetic, trigonometric, you can use this and you can get the result within short span of time. But one thing which you have to take care is like whenever there is a function, like under root of x sin x, then in this case you can't apply this formula because it will take you to integrating and integrating you'll do, but you will not get any result. So guys, all you have to do is you have to take care of this Euler rule and just keep on priority which function you can take first and which function you can take second, then you can do this equation. Thank you.